On this one, we're taking the limit as x goes to infinity. So I'm just gonna plug in the infinity there, plug in the infinity there, plug in the infinity there. So what do we get? 11 times infinity times e to the 1 over infinity minus 11 times infinity. Now, what is 1 over infinity? Well, that's zero. You clear on that? That's going to come up a lot. Why? Because if you divide by like a infinite number, like a million, let's just do a million. What is 1 over a million? What if I'm going to give you 1 millionth of a candy bar? That's basically no candy bar, right? It's basically zero, right? 1 millionth. And we're doing the limit. Remember, the limit is where you're headed, right? So where are you headed? If you go 1 over a million, you're getting really closer. 1 millionth of a candy bar is virtually just crumbs. Maybe just the smell of the candy bar. It's almost nothing, right? That's only a million. We're going to infinity. So billion, trillion, on we go. It's headed to zero. So 1 over infinity is zero. So this is zero. So this becomes e to the zero. 11 infinity e to the zero. That's where it's headed. Remember, it limits where you're headed. And what's e to the zero? What's anything to the zero? E's just a number, right? E's just 2.7 blah 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 to the zero power. Any number to the zero power is one. Okay, so what? Then 11 times infinity times 1. Well, that's infinity. Minus 11 times infinity, that's infinity. Infinity minus infinity. That's zero. No, no, no. That's unclear. We call it indeterminate. That's the official math word. Indeterminate, meaning we cannot determine what it is. It's unclear. We can't determine the answer. You might think, yeah, we can. We talking about infinity minus infinity, zero, clearly. No, no, no. It depends how fast those things get to zero, right? Like if you're make it real. If you're launching two rockets into outer space, if one of them's going twice as fast as the other, then the difference between them, like in the first second, might be that, and then a second later, the gap has grown. See, the gap, the difference between them isn't, they're both going to infinity. They're both infinities, but one's going way faster. So the difference between them is actually growing. It's not zero. Anyway, we don't know. We don't know which one's growing faster, equal, whatever. The fact is we just don't know. It's unclear. It's indeterminate. You can't know what infinity minus infinity is. All right. All that to say that didn't work. We plugged in the infinity. It was a big pain in the behind and nothing good happened. So then what are we going to do? We got to try something else. So here's what we're going to do. We're going to factor. We love to factor, don't we? So what can you take out? I'm going to take out 11x, and that leaves e to that minus 1, right? Did I do that right? 11x, boom. 11x e to the 1 over x, and boom. Yeah, okay. So that's right. So I factored. Okay, great. So what? What does that do for me? Um, let me erase all this silliness, which really didn't get us anywhere. You can look back on the video if you want to see it again, but it didn't get us anywhere. So, okay, so what are we gonna do now? If you plug it in right now, it's still gonna be infinity, right? And plug in infinity here, that's gonna be e to the 1 over infinity. So that's e to the 0. And 11 times infinity is infinity. And e to the 0 is 1. That's infinity times 0 now. See what I did? I just plugged in the infinity after factoring, and 11 times infinity is certainly infinity. And remember, we already said 1 over infinity up there in the power zone is 0, right? 1 millionth of the pie or the candy bar or whatever. 0, e to the 0 is 1. So it's infinity times 0. What's that? Well, that's clearly 0. No, that's indeterminate also. You might think, what? What are you talking about? It's unclear. What do you mean it's unclear? Anything times 0 is 0. Well, yeah, that's one rule. Anything times 0 is 0. But there's another rule. Anything times infinity is supposed to be infinity. Which one is it? We're just not clear. It's indeterminate. We can't determine it. No, this is an unclear, indeterminate form because it basically, you might think, no, come on, Mr. Aaron, 0 times anything is 0. No, no, no. The problem is, remember, it's a limit. So it's just getting close to 0. It's not exactly 0. Yeah, if it was exactly 0, you're right. Anything times 0 is 0. But it's not exactly 0, right? X is just headed to infinity. which means this is 1 over a very large number getting closer and closer to infinity, which means this is close to 0, e to the 0, which means this is close to 1, and 1 minus 1 is close to 0. But it's not exactly 0. It's just really, 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 really tiny times something that's really, 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 really big. So that's just unclear. So you got to remember whenever you have like a 0 like that, it's not really a 0. It's just close to 0. It's really, really tiny times something really, really big. That's unclear. It's indeterminate. We don't know. Okay, well then this is a bunch of dead end streets. No, we can do it. We see how it says Lopi. Now remember, we want that's pronounced L'Hôpital's rule. It's French. Anyway, it's not, you don't say La Hospital, but that's fine if you do, whatever. It's L'Hôpital's rule. So now to use L'Hôpital's rule, we have to have 0 over 0 or infinity over infinity. That's what you cannot use Lopi until you have 0 over 0 or infinity over infinity. So somehow we have to take this limit. Here's the trick that you got to get used to in this L'Hopital section. You got to take this limit, which currently 11x times e to the 1 over x minus 1 is coming out, infinity times 0. That's not helpful. We got to make it a fraction. See, to use Lopi, you got to make it a fraction. So, well, how can I do that? Here's what we're going to do. We're going to take that 11, we're going to leave the 11 and the e to the 1 over x over 1 and put down here 1 over x. Yeah, do a better job on that. Do you see that's the same thing? Hold on, what do you mean I said that 1 over x could flip back up and it'd be x over 1. It would just be x. It's the same thing. I just grab that x and move it down as a 1 over x. Remember, dividing is upside down multiplying. You know what I'm talking about there? To divide by 1 over x is the same thing as to multiply by x on the top. Remember, things in the denominator, they can flip back up, x over 1, or flip back down, 1 over x, right? Turn upside down. And it's the same thing, right? I don't want that to be mysterious. Real quick. If I take 10 and divide by 2, we know that's 5. If I take 10 and multiply by a half, half of 10 is also 5. We see that dividing by 2 is the same as multiplying by it's upside down. That's why it's true. Multiplying by x is the same as dividing by it's upside down. Multiplying and dividing are just upside down. So that's the same thing. Okay, great. So what? Who cares? Now plug in that infinity. Put infinity here. Put infinity there. What are you going to get? This is going to be 11 times e to, remember this is e to the 0, right? Over 1 over infinity. And what's that? E to the 0 is 1. And what's 1 over infinity? We already said that's 0. See what we're getting? 0 over 0. Okay, great. So what? It's still dead and straight. Yeah, but now it's a license to drive the car. Now we can do Lopi. We can do L'Hopital's rule now. So I know we've worked on this a long time. We still haven't got an answer. But what I'm saying is we're almost there now. Now we can take this and we can do L'Hopital's rule. We rearranged it. See what we did? So we rearranged it. So now I'm going to write limit as x goes to infinity of 11 times e to the 1 over x minus 1 over, I'm just going to make it x to the minus 1. That's 1 over x, right? Because, now why am I doing that? Because now in that form, we've already proven that's 0 over 0. And when you get something into a form that's coming out 0 over 0, you're allowed to use L'Hopital's rule, which they said in the beginning. Use L'Hopital's rule. All right, I know there's been a lot of work here. So again, let's I took this and I rewrote it as a fraction. Dividing is upside down, multiplying. I moved that 1 over x down there. Then I plugged in the infinity and I saw it was 0 over 0. So that gives me a license to use Lopi. So now we're going to say, okay, let's do Lopi. So we like to put an H, you don't have to, but just a way of saying, hey, I'm using Lopi. Lopi is a special rule. And what are you going to do? What is the L'Hopital rule? It says you can do the derivative of the top and the bottom separately, not quotient rule. Just derivative of the top separately. So it's actually supposed to be the limit still in front here. I'm kind of being A little too casual. Okay. You know what? I'm probably just running out of room here. Um, because I scribbled all this over here. All right, whatever. Let's do the derivative of the top. So this is out of the way. Oh, what? I was on the wrong tool. Okay, let's just get this stuff out of the way. Okay, let's do the limit of the top. Let's do the derivative of the top. How do we do the derivative of the top? Well, 11 just sits there. How do you do the derivative? Oh, that's going to be a little complex, huh? All right. Let me, sorry, this is taking a long time. I didn't realize it's this complex. Okay, so let's try again. So 11, I'm going to write this e to the x to the minus 1. Minus 1, right? And the bottom, same thing on the bottom. Okay. Now let's do Lopi. I'm going to put an H there. I'm doing Lopi. What comes now comes from Lopi. L'Hopital's rule. Okay, so here we go. Take the top and do the derivative of just the top. What's that? The 11 will sit out front. Okay, now how you do that? How you do the derivative of e to something? Remember, he's our favorite one. He does nothing at first, but then chain rule, because the inside is not a simple x, it's x to the minus 1. You do the outside, the inside stays the same at first times. Chain rule says derivative of the inside. Actually, that's just 1. And then this part's just 0. So there we go. Now derivative of the bottom, minus 1 comes down. Oh, wait, no, I'm sorry. That was a total mess up. That's because I can't read my own writing. I thought that was, sorry, I am just muffing this thing. Let's try this again. Derivative of the top, the 11 just sits there. Okay. And then e to the x to the minus 1 times the derivative of the inside. Now the derivative of the inside, which is this, the minus 1 comes down, x to the minus 2. There we go. That part is 0. That's probably what you were wanting. Another derivative of this guy, minus 1 x to the minus 2. All right. I just did the derivative of the top and the bottom separately, which is that h is indicating I just used L'Hopital's rule. I'm allowed to because it's 0 over 0 right now in this format. So I did the derivative of the top. Again, that was a little tricky. How you do e to anything? He does nothing at first, times, according to the chain rule, the derivative of the inside function, which is that. Okay, great. So what? Well, now these cancel. See how beautiful that is? And so we have the limit as x goes to infinity. What do we have left? I think we're almost there. We have 11 e to the x to the minus 1 over nothing, just 1. In fact, I'm going to go back and rewrite this as 1 over x again. So now, so the bottom is just 1. So now let's try. So what you do is you do Lopes and then you plug in the infinity again. So let's plug in the infinity. This will be 11 e to the 1 over infinity. Oh, I don't leave the 1 on the bottom. That's e to the 0. That's 11 times 1. That's 11. And there is our answer. That was a lot of work, wasn't it? So there we go. So recapping real quick. So from the beginning, I tried plugging in the infinity and I just got infinity minus infinity, which is unclear. Then I thought, okay, I'm going to factor. And I plugged in infinity again. I got infinity times 0, which is also unclear. And I thought, oh, I got to make it a fraction so I can use Lopi. So then I made it a fraction. I took that x and put it on the bottom as 1 over x right here because dividing is upside down multiplying. Then I plugged in and I got 0 over 0, which is still unclear, but tells me now in that form I can use Lopi. So then I did. So I says, all right, Lopi time. There's the h. I took the derivative of the top separately, bottom separate, not quotient rule, just top, bottom separate. And then sure enough, something nice happened. Those canceled. I just got this, plug in the infinity again. E to the 0 is 1. It's 11. And there we go.